Okay, now we are going to move to section 2.2, which is talking about the equation of a line, and do problem number 22, for example, in section 2.2. Here in this chapter, they talk about the equation of a line. Again, equation of a line normally takes this form: y is equal to mx plus b, where m is the slope and b is the y-intercept. So in this example number 22, it says find an equation of the line that has the slope m and intercept b. And in this case, in number 22, it tells you m is equal to minus 1/2 and b is equal to 3/4. So all you have to do is to plug these numbers into this equation. So you get y equal to minus 1/2 x plus 3/4. That's all you have to do here. This is the equation of a line with the slope of minus 1/2 and the y-intercept of 3/4. Let's look at another example. Say problem number 44. These are the problem where they ask you to sketch the straight line. And number 44, the line is minus 2x minus 8y plus 24 equal to 0. Now normally for the sketching of a graph, what I like to do is make myself a t-table. I put x on one side, y on the other side. And since this is straight line, all I need to draw a straight line is 2 points. The simplest one to find is, I say, if x is equal to 0, how much would y be? And you can see if x is equal to 0, here you would have minus 2 times 0 minus 8y plus 24 equal to 0. This, of course, would be 0, so you would have minus 8y equal minus 24. Y, therefore, is equal to minus 24 divided by minus 8. Therefore, y is equal to 3. 3. Then I say, what if y is equal to 0? How much would x be? Well, when y is equal to 0, then minus 2x minus 8 times 0 plus 24 equal to 0. Therefore, this would be 0. Minus 2x equal to minus 24. X would be equal to 12. That is when y is equal to 0. This would be 12. Now, those are the only 2 points I need to sketch this graph. Then I do the Cartesian coordinate, the x-axis and y-axis. The intersection is 0. Then I choose the scale. I look under my x column and I would see 0 and 12. So I want to choose the scale so that 12 would end up not getting out of the page. So let's say we use this to be 2, 4, 6, 8, 10, and 12. And on the y-axis, I can have a different scale because I need 3. 3 is the highest number I have. Let's say I use this to be 1, 2, and 3. I can continue 4 and so on and so forth. Now, the first point on this line has the coordinate of 0 and 3. X of 0, y of 3. That would be right here. Right here is 0 and 3. And the second point has a coordinate x of 12 and y of 0. 12 and 0 would be here. If I connect these 2 points together using a straight line, I can continue actually. This line would represent this equation. Of course, if I was going to show the slope and the y-intercept here, put it in the format of y equal mx plus b, from here you can see I can solve minus 8y equal to 2x minus 24 and divide everything by minus 8. Y would be equal to minus a quarter plus 3. And as you can see, the intercept as shown here is the y-intercept is at plus 3, and you can see that right here at 3. The slope, again, you can look at the rise over run, which is 3 over 12, which would be quarter. There is an h here, which would be a quarter. So that's solution to that. Let's do another problem. From the same section, section 2.2, problem number 48. It says use the results in exercise 45 to find an equation of a line with the x and y intercept. And here in number 48, it tells you that the x-intercept is equal to minus 1/2, and the y-intercept is equal to 3/4. Now, if you look back to problem number 45, it says show that an equation of a line through the point A and 0 and B with A not equal 0 and B not equal 0 can be written as x divided by A plus y divided by B equal to 1. Recall that the numbers A and B are the x and y intercept, respectively, of the line. This form of an equation of a line is called the intercept form. So in the intercept form, this A is referring to the x-intercept, and B is your y-intercept. So all I have to do is to plug in those numbers for A and B. So I would get x divided by A, which is minus 1/2, plus y divided by 3/4 equal to 1. I can simplify this further. X divided by minus 1/2 is minus 2x. And here would be plus 4/3 y equal to 1. If I want to put this in the form of the general form of equation of a line, I can solve for y. So it would be 4/3 of a y equal to 2x plus 1. Therefore, y, divide everything by the coefficient of y. Y would be equal to 2 divided by 4 third x plus 1 divided by 4 third. Therefore, y is equal to, this would be 3 half x plus 3/4. Now this is of course the same as this, and they both are the same as this. It's just writing it in different forms. They're all the same equations. Let's do, I think we got one more problem I want to do from this section 2.2. Problem number 58. Do problem number 58 from this section. Sales of navigation systems. The projected number of navigation systems in millions installed in vehicles in North America, Europe, and Japan from 2002 through 2006 follow, where x equals 0 corresponds to 2002. So here you got the years. Year 0, 1, 2, 3, 4, again corresponding to 2002, 2003, 2004, 2005, 2006, and systems sold or installed, navigation systems. In 2002, 3.9 million. In 2003, 4.7 million. 5.8 for 2004. 6.8 for 2005. 7.8 for 2006. These are the information given. A, it says plot the annual sales versus year. Normally, for the Cartesian coordinates, they put year on the horizontal axis. Here is 0. And system sold, the variable, on the vertical axis. So let's say the years go from 0, 1, 2, 3, 4. And for the systems, let's say, what are the numbers? Let's say we got 5 million and 10 million. Any pair of these numbers would give you 1 point on this graph. This is like the x coordinate, and this is the y coordinate. Same thing here, 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 and here. Each pair would give you 1 point. So first is 0 and 3.9. 0 and 3.9, if this is 5, 4, I say 3.9 is right here. This is 1 point. Next is 1 and 4.7. 1 and 4.7 probably be close, very close to 5. Let's say here is the next point. Next is 2 and 5.8. 5.8 probably about here for 2. Next, 3 and 6.8, 6.8, 7.5, 6.8, lower. I'm just estimating where it would be. Four and 7.8 would probably be about here. Those of you who have had any statistics, you remember the scatter diagram and regression analysis and everything. This is basically that kind of problem. This is called the scatter diagram, or plotting the points. Then it says, draw a line, draw a straight line L through the points corresponding now these points is not exactly on a straight line, and it would not be, but if you just take the first point and the last point and you connect them together, this is the kind of line it wants you to do. And don't forget, this first point, the y-intercept is at 3.9. We remember that one for one thing. So that is B. C, derive an equation for this line. Well, we know the intercept would be at 3.9. That's kind of easy. All we need is to figure out the slope. Now we remember the formula for slope. M is equal to y2 minus y1 divided by h2 minus h1. Oops. Now I can take any points on my chart to be y2, the second point and the first point. Let's say this between here and here, if you want. Since we are talking about a straight line, or I can take the first point and the second point. Let's say this is the first point. Let's forget about this other one since I'm using 3.9. These 2 points. Okay, y2, y is talking about the number of systems. Oops. Y is talking about the number of systems. So take y2 to be 4.7 minus y1, which is 3.9, divided by h2, which is 1, minus h1, which is 0. If you do this, you would get the slope to be 0.8. Well, if the slope is 0.8 and the intercept is 3.9, then, and you know y is equal to mx plus b. In this case, m is 0.8 and b is 3.9. So y is equal to 0.8x plus x plus 3.9. Now, one qualification here would be, since I took the first point and the point 4 here, 1 and 4, and the line goes through these 2 points, then maybe as my first point, I should have taken the y-intercept, and as second point, take the last point for 2006. So this is number 1, this is number 2. So when I'm calculating the slope here for y2, I would use, let me redo this. and see how much the difference would be. It should not be that big of a difference. You use the first point and the last point. So y2 is referring to 7.8, y1 is 3.9. So 7.8 minus 3.9 divided by h2 which is 4 minus 0. So if I do this, 7.8 minus 3.9 is 3.9 divided by 4. And 3.9 divided by 4 would give me the slope equal to almost 1, but 0.975. 3.9 divided by 4 would be 0.975. Now, then y would be equal to this slope, 0.975x, plus the intercept, which is at 3.9. A little bit different than the other one. Probably more accurate, and the reason I took the first and the last point is because what I chose was the last point and the first point, and you connected the 2 points together to get the line. It just happened to go through the third point also. But since it didn't go through the through the second point, or for h of 1, I should not have chosen that point. So this is probably a more accurate equation for the line. I think there is one more question. It says, use the equation found in part C, which is this one here we have, to estimate the number of navigation systems installed in 2005. Compare this figure with the projected sales for that year. So again, this would give you an estimate. If I plug in 2005 means what? 2005 means x is equal to what? Right up here, 2005, it means x is equal to 3. So if I go ahead and plug in for x here in this equation, if I go ahead and plug in for x3, then that means y is equal to 0.975 times 3 plus 3.9. Then y is equal to 2.925 plus 3.9 equal to 6.825. That is approximately 6.8 million is the estimate for 2005. That's the estimate for 2005. And of course, the actual number we have is the one that gave us to in the table. Oh, it happened to be 6.8 also. 6.8. That's pretty good. That's a pretty good estimate. 6.825 or 6.8. And I actually am proud of myself drawing the picture here. It actually went through this point for number 3 for 6.8 million sold.